Oh, we're going to talk about lists. If I can find the correct PowerPoint. All right, let's see where we ended up. Okay, so we've been talking about reference variables this whole time. So we talked about here's how to actually construct that house that we made. We talked about instantiating something. We tested out different operations. The general consensus is the equality and the assignment operators. Those all work fine. But it's the arithmetic ones, like your plus, minus, multiply, divide. Those don't fly because I don't know what it means to add two houses together. So that's kind of where we're at. We talked about how an object is an instance of a non-primitive type. We looked at how do we actually use those behaviors. So we used something called the dot operator. So we have some variable name, dot the method name, where the method belongs to that type. And we know that because we have a house class, a house type that we defined, and we said it's going to have this open front door method. And so we use that with the dot operator. So we say house1 dot open front door. We looked at what happens when we print it. We briefly talked about garbage collectors, and then we went over something that you'll need for lab 2, which is array reallocation, which is where arrays have some fixed size as we go. And if that fills up, then, and we need more space, we can't just like add one spot to our array. We've got to start from scratch, make a bigger one, copy everything over. So that's the idea here, where we make a bigger box and then we copy all the old ones over. And then finally we copy that new thing over as well. So this is one of your tasks that'll be on lab 2. So the big idea is create a new array. How big do you want the size to be? That's something that you need to think about. Copy the old things over and then only work with a new array. We looked at strings, where strings are just a sequence of characters. They're defined by those double quotes and not single quotes. The single quotes are just for characters. Double quotes are for strings. And if you try it out, like if you try to be like, string s equals whatever, it's going to get mad at you and say, this is an invalid character. Because it's not like a bunch of characters is not a single character. So that's why it's not going to be happy. And that's the thing with Java a lot of the time, which is something that I still do, even though I've been teaching this class for 7 years or something like that, where I'm like, does this work in Java? Let's try it out. And then this happens to me with like length and size all the time. I'm not sure which one something uses. So I try one, and if that works, great. But if not, then I'm like, okay, it's got to be the other one. So there's a process of elimination that can happen. We talked about concatenation, how concatenation is like smushing two strings together. And we can do that with plus equals. We need the equals because it reassigns, because once we have a string, we can't change it. So if we need to make a change, we need to replace it. So we replace whatever we had that we don't want anymore with the new version. We use .length to find the length of a string. This is the one that I get confused on all the time. If we want to get an individual character, we use .char at and give it an index. To get a substring, this is similar to slices in Python. We use the .substring, and so we have some place where we start and then a place where we end 1 minus that. So just be careful as you go, test it out if you need to use a substring to make sure you're getting the portion that you want. And then we briefly talked about like comparison. So one of the options for comparison is like how long it is. Another option is where does it live in the dictionary? And so we talked about compare to, where we can compare one string to another. And the method for comparison that this method uses is the dictionary ordering or lexicographic ordering. And that comes from the Unicode table, which is why there's a problem in the packet of compare capital A aardvark to lowercase a aardvark. And capital A aardvark comes first because that's how the Unicode table is defined, where capital A has a lower value than lowercase a because the capital letters come first. And then finally, I think we looked at parsing, which is where if I've got some string that I want to save as another kind of value, I can do that with, if I have, especially if I have a string that I want to save as a primitive value, then there's a secret reference variable type for all the primitives to let you do more intense things than just add, subtract, multiply, divide. And so that's where like capital D double comes in to help me parse this 3.14 number. You'll use this with definitely lab 3. When in lab 3, I'm going to give you a file of like soccer teams, win, loss, and draw. And so I'm going to ask you to parse the integers in that file. And so you'll use something like this to do that. And then we talked about for each loop, which is another way of going through this box of candy. The way it looks in Java is we've still got the for, and instead of having an index to keep track of where we are, we'll have a collection. And we're going to say we're going to start at the beginning of the collection and iterate through and take each thing at a time. So for our box of candy, we'll say I'm going to have a candy variable. That's what's going to hold each piece of candy as I go through the box. So first it's Rolos, then it's an M&M, then it's Twizzlers, then it's the Milky Way, and so on. So we need to say, here's what type of thing it is. Here's what I'm going to call it. That's the variable name. So that's for the type would be, I don't, if we've defined a type, it would be capital C candy. If we haven't defined a type, it would probably just be a string. Like this is just a list of strings. And so would be for string candy in bag, then sys out candy. And so the way we type in instead of the word in, it's the colon. Not a semicolon, just a colon. For strings, if we want to split it up into characters, we do that string variable dot to char array. And I believe we had an example, yeah, this one, where S4 here was my name is Sarah. And so this splits it into individual characters and it prints one character a line. And then we also had dot split where we give it a string. And then that splits it according to spaces. So it's going to give you an array of individual word strings. Just to note that split actually, if we tried to give it just a character instead of a string, it doesn't like that. It's not set up to handle a character. So it does in fact need double quotes there. And so this is something I'm getting ahead of myself, but I was just finishing up lab 3, so that's why I'm thinking of it. For lab 3, I'm going to give you a file that's separated by commas, so you'll just need a comma there instead. Okay, and that's split. Any questions on what we covered last time? Anything you want me to go over again? Cool. Let's talk about lists. So we've got arrays. Those are all well and good. But some things about arrays are annoying. Like we have to reallocate them if we fill them up. We can access it by index, but there's not really, we don't have much of like a reference type methods available to us. So Java has a way of handing us an object to store things in, like an array, but it does some of these things for us. So it'll do reallocation for you, and it has some other things that arrays don't. So for example, let me make a new file just to test for today. Today's the 27th, and I need a main. Okay, so let's say I've got my string, and let's split it and save it as an array. So I need the left-hand side of the equal sign to be, here's the sort of thing that's going into the array. It's a string. Then I need the empty square brackets to say this variable is going to be an array. I'll say these are my string words, and I'm going to say s1 dot split, and I want to split it by spaces. And let's say I want to print that now. If I were in Python, it would print like my list, my comma name, comma is, comma Sarah, right? But here it doesn't do that. It just prints the hash code. And it's got this, which says it's an array. It's got the bracket here. So this is one of the things that lists is going to let us do. It's going to let us print something. And that's nice. Thank you. So a list is going to have a feature that lets us print something, and it has other things that we can do with it as well. The way we set it up, it's going so to declare, we need list, and then we need what I call angle brackets, because if you're familiar with LaTeX at all, which is the way that you type math, in LaTeX it's typed langle for left angle and wrangle for right angle. So I call them angle brackets. They're less than, greater than. They're the comma and the period on your computer when you press shift. So we need to say that this type of variable is a list. And similar to arrays, we need to say, here's what's going in there. So we need to say the item type. And so inside those angle brackets, that's where we say, here's the type of thing that's going to live in my list. And then we've got the variable name just as normal. So this is how we declare that. To instantiate it, we need the new keyword like we did before with house. We've got our variable name equals new. And then on the right-hand side, this is where we need to specify what kind of list it is. So you'll see me using array list. There's also a linked list option. We'll talk later in the semester about what a linked list is, but I'll use array list. And then we need sometimes you need the item type again. Sometimes you can just leave it blank. And then the open and close parentheses, and that calls the constructor. Or you could do it all in one line like this. So we need the right-hand side. So we've got list over here, but array list over here. That's because of reasons. We'll talk about that later. So let's test it out. So we have a list, and if I start typing the left angle bracket, it gives me the right. And so the thing in there is strings. And list words, I'll call it. Could be anything. And so then to set up an empty list, I'm going to have new array list. Let's leave that empty and see what happens. And then just type empty, open, close parentheses, and then semicolon. I've got an error here. That's usually resolved by hovering over it, and it says array list cannot be resolved to a type. These things live in Java util, and so I just need to import those and tell Java, like, yeah, I want to use that one. Because the options are import it or make my own. So I would like to import it. And then I believe I need to import list as well. And once I do those two things, errors go away. I'll give you a second. Let me know if the errors did not go away for you. Errors did not go away.
Yeah.
Did the errors go away?
I was busy fixing something in my strings class.
So we're doing the comment, like, you write that last line of code. That's what we're doing.
I can't see.
Do you want to move your chair a little bit to the right?
Hang on.
Arraylist. Cool. Is it yours not go away for anybody else? No errors? Cool. Let me know when you're ready. Ready? Okay, so now we've set it up. We've instantiated our empty list. In terms of how to use it, we can't use the square brackets to access indices anymore. That's just because we're using a different kind of object this time. But we can use dot operation methods. So like to add something, we can say dot add item. And so if we, maybe if we want to add everything in, I've got my string words array already, so let's just use that. So 0 won't go away. I'll be there in just a second. I less than, I want to go through my array of words. So let's say string words dot length I plus plus. And so then I'll say list words dot add.
Oh, wait, was I supposed to import Java util?
Yes, that's what makes the errors go away. So you're gonna add string words at index I. So we're adding is what adds to the end. It's similar to append in Python. Okay, are we good to go back to the slide? So add adds it to the end. Add last does the same thing. It's equivalent. Add first adds it to the beginning, as you may imagine. We can remove things where we can say, remove a specific index. For remove, we can remove individual items. So like if I have the word my in there, I can say remove the word my. And so that's going to take out the first instance of that item and then return it. These two can get tricky if the things in your list are integers. Because if you think about it, if you're trying to remove an index, but the data type is also integers, then it's going to be like, what are you giving me? So just be careful about that. Dot clear removes everything, clears it out. Dot get, this is the equivalent for this. So if I say dot get I, that's equivalent to string words at I. Okay, after we do this, let's print list words and just, so see now when we print a list, it actually knows what to do when we call print. So that's nice. That's useful. It doesn't add the quotation marks, but we know it's a string. Get first, get last. I feel like those are self-explanatory. It gives you the first thing and the last thing. For how many things are in it, it's dot size, open and close parentheses. This is the one where it messes me up. To check if something is in there, you can do dot contains, which gives you true or false. So let's try, bless you. List words dot contains, and let's check if my name's in there. We would expect this to be what? True or false? True, because my name should be in there. And it is. Hooray! It's working. We can print a list like we just saw, unlike arrays, which just give you a hash code. If you want to print an array, you've got to write a for loop and then go through each thing and print each thing. So that's a little bit extra work. And I think that's it for lists. So now we really are truly, I promise, doing lab 2.
I
Okay.
didn't get it.
We didn't go through each one of them, but this code will be posted to Canvas after class as well. Just like every day. And it lives in the lecture links page, and it will live where it's going to say today's date and then under files. Okay. So lab 2. Let me walk you through it. So lab 2 helps you practice the for each loops, array operations, and some string operations. The string operations is a little bit tricky, but I think it's really fun. So number 1, you're going to clone it. I'll walk through that in a second. I'm just going to go through the instructions briefly. So this is one where I think every beginning, middle, and end all have test cases. So all of them have test cases today. So for beginning, you're going to look at the find number in array and then write out what the loop is doing. And so this is practice for writing comments. And so the number 3 is to look at get even numbers and find an array full of even numbers, or get the array using a for each loop. So you're going to write that loop that gets all the even numbers. I will show you in just a moment. Actually, I think I would like to clone it, so that way I can refer back to the code. Okay, so if you're on this page, then go to the green button, and then there's a little copy URL to clipboard. And then I'm going to go back to Eclipse. I'm going to go to the Git perspective, which for me is in the top right over here. There's a little gold cylinder that says Git. And then over here on the Git repositories side, there's 3 things with gold cylinders. I'm looking for the one with the green arrow, the cloud and the green arrow, for clone a Git repository. Then we do clone URI next. That's the repository path. We don't change that. Next. The branch selection, yeah, that's fine. Here's where I make the change. So I'm going to say, this is where it lives on my computer, and I'm going to name the folder Sarah R dash CS222 Lab 02. And then make sure that the box for import all existing Eclipse projects after clone finishes. Okay, are we good?
Did you walk through that?
Yes. So this is my Package Explorer where I'm writing Java things. First, I need to go to the Git perspective, top right. Click on that. I can also go, I think, window perspective, open. Nope, I guess not. I thought maybe I could. Apparently not. Okay, so Git perspective. Then over here on the left, there's a little icon with the green arrow that says clone a Git repository. Click on that. Clone URI. And then for me, it auto-fills from the clipboard, or otherwise you just paste it. Next. The main branch, that's fine. Next. Here's where I make the change. This is the local destination. So I'm saying I want to save it with my name in it. And then make sure to check that box to import it after we're done. Anybody want me to go through that again? Which part?
All of it.
All of it? Okay. One more time. I'm in the main Java perspective. Click the button to go to the Git perspective. Yeah, Git perspective. Over on the left, there's a button with a little green arrow. Clone a Git repository. Clone URI. Next. It auto-filled that from the clipboard for me. Next. Main branch, great. Next. Here's where we make the change, the local destination. And then, yeah, so name and then and last initials. And then finish. So then down here, it shows the progress. And so I've got lab 2 over here. Let's go to the Java perspective and see if it is over here. Mine doesn't look to be over there either. How do I fix that? Let's go back to the Git perspective and find it over here. Mine's right here, lab 2. You can right click and then click import projects. And then, yep, and then finish. And now I should be able to go to the Java perspective, and here it is. Okay, I'll walk around in a bit and make sure everybody's got that. But does anybody have any errors that are completely popping up? I think I found the issue, but there's always a possibility. Hooray. Okay, let's go back through the instructions. Okay, so for beginning, find number in array. Your task here is to write a comment. What's it doing? Find letter in string. It's not in the correct order, I think.
Says find number in.
Find number in array. Oh wait, but there's no get even numbers.
That's all numbers.
So I guess, sorry. So I guess well, let's modify the instruction for number 2 of make a get even numbers method. Which returns an array full of even numbers. And so 0 through 10. You can just hard code 0 through 10. So number 3 is make the method. Should return an array full of integers. Number 4 is find letter in string. And so you'll use the toChar array to convert some string to this character array. And you've got the target, and you want to know if this target character is somewhere in that array. So write a for each loop and then write some logic to return true if you find it. Otherwise, return false. So maybe you want to change this return statement. Maybe you don't. That's up to you. And then I would like for you to get in the practice of writing comments as you go. So once you write your method here, write a comment of this is how I did that. Just in plain words, here's what I did. I'll be there in a moment. And then for that one, we do have beginning tests. So I would go to the test folder in the source folder, beginning test, and then run that. So one of them passed, but the rest of them didn't. Okay, so that's beginning. For middle, the main task is to implement reallocate. So let's show you what that is. So I gave you a method split to letters. And so it's taking in 2 strings, and the goal is to split each into a character and save them all to one array. So if I have hello in one and hi in the other, I want an array with characters HELLO, HI. That's the goal. And so your job is to call reallocate and implement reallocate down here of how do you actually reallocate this this array. That's the goal. For end, this one is a little bit tricky. Explanation. So for end, how many of you have read or seen A Series of Unfortunate Events? Okay, at least 2.5 people. So A Series of Unfortunate Events is a popular series. In the book, it's all about like secrets and stuff. It's a kid's series. In the book, there is a code called Sebald Code, where the secret message starts when a bell rings, and then every 11th, so the first word after the bell, and then every 11th word after that is part of the coded message. So like I have one word, and then I've got 11 words of just nonsense that you can ignore, and then the word after that is the next word in the code. And so the 10 in the middle, you can ignore those. And so then the secret message ends when a bell rings again. That's Sebald code. So you're going to be given a long string. That's the entire message. And you want to iterate through the loop. I don't care which kind. It could be a for each loop. It could be a regular for loop. That's up to you. And maybe use some counter to keep track of how many words we're at. And maybe have some variable to register whether we're in the secret message or not. Because the ding, so the bell is, in this case, you can assume is literally the word ding. And so once the bell starts, then we can decode the secret message. After the bell has rung, then we're stopped, the secret message. So yeah, so I've got some ideas for, here's like vague pseudocode for what I did for my solution. And so you can take this and implement it, or you could come up with another way. So this one is going to be like a little bit harder because, but I hope it's also fun because you're decoding a secret message. And then once you're done, zip the whole project folder. If you have questions for how to do that, let me know. And I think we're off to the races. Let me edit this. Implement get even numbers, which is a static method and returns let me commit the changes. Let's see. I'm not used to doing this in Eclipse. So there should be a way to pull. So if I right click on here, this is the lab2 that I cloned. I can pull. And oh, look here. I've got update readme. Update result. Do I have to expand that? No, I think just close. So if you go back to the Git perspective and then you click pull, one of the two, I don't know that it matters. Then I think let me go to the README. Yeah, it's changed. Hooray. Okay, any questions? All right, I'm going to stop recording and then put you guys in groups and we're good to go. So the plan is I'm going to assign pairs. We're going to work on it for the rest of class. If you don't finish, then you just have to connect with your partner and finish it outside of class. And as usual, only one person has to submit the code. Both people should understand what's going on and be able to do it, but only one person has to submit it. And next time we'll talk about input output.
Now.
Yes, I'll be right there.